Hello friends, now we are finding what is electric potential due to an electric dipole. We already learned the term electric potential and calculated what is electric potential due to a point charge. Now by using that concept we are going to find what is electric potential due to an electric dipole. Remember, an electric dipole is an equal and opposite charges separated by a very small distance. Here we have an electric dipole like this. Suppose this is an electric dipole. This is negative charge, this is positive charge. Length of the electric dipole is 2a. We have electric dipole moment of this electric dipole is P, which is a vector quantity, product of either of the charge and the length of the dipole directed from negative charge to positive charge. This is the center of the dipole. First, we are finding what is electric potential due to this dipole at a point on its axial line, which is at a distance r from the center of the dipole. Consider a point S which is at a distance r from the center of the dipole. So to calculate what is potential at the point at a point S, first we will find what is potential due to this positive charge, and then find what is potential due to this negative charge. As these are the scalar quantity, potential is scalar quantity, we use algebraic addition to find total potential at a point S. So first we are finding what is potential due to positive charge. Potential due to positive charge, V plus Q is equal to, potential due to positive charge is equal to, what the equation, 1 by 4 pi epsilon 0 Q by distance to the point is what? Up to here we have A, and from here to here it is R. So it is R minus A. So it is R minus A. This is positive quantity because this is the potential due to a positive charge. Now find what is the potential due to negative charge here. The potential due to negative charge, V minus Q, is equal to again 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, Q by distance to here, it's R plus A, is it? R plus A. From to here it is R, then A, R plus A. This will be a negative quantity because this is the potential due to a negative charge. Now what is the total potential at S is the sum of these two quantity, algebraic sum. That is, total potential is equal to V plus Q, okay, plus V minus Q. Add them. That is, V is equal to 1 by 4 pi epsilon 0 is common, and inside the bracket we have Q by R minus A plus minus, so it is minus Q by R plus A, Q by R plus A. Okay. Now total potential is V is equal to, take Q also outside, Q by 4 pi epsilon 0, Q by 4 pi epsilon 0, and inside the bracket take LCM, R minus A into R plus A, and here it is R plus A minus R minus A. What is that? V is equal to Q by 4 pi epsilon 0, Q by 4 pi epsilon 0. This will become 2 times of A by R square minus A square. That's it. Rearrange the bracket. V is equal to 1 by 4 pi epsilon 0. We are writing 1 by 4 pi epsilon 0 into Q into 2A is what? That's our dipole moment. P is equal to Q into 2A. So instead of Q into 2A, we are writing as P by, and quantity R square minus A square. The substitution that we used is what? We have P is equal to Q into 2A. The electric dipole moment of our dipole is Q into 2A. So instead of Q into 2A, this substituted P. So this is electric potential at a point on its axial line. Suppose if our dipole is too short. Short means its length is too small comparing to the distance to the point S. So by the time we can use an approximation is R is very much greater than A is negligible in this equation. That is, V become for a short dipole, for a very short dipole, V is equal to what? 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0 into, okay, 1 by 4 pi epsilon 0 into P by R square. That's it, R square. The second term we just neglect it. Now, this is electric potential due to an electric dipole on its axial line. Suppose instead of axial line, if you want to find what is electric potential at a point on its equatorial point. Now instead of this axial point, we taking a point on its equatorial line. Let us see what is that. For that, potential at a point on its equatorial. Okay, at a point on its equatorial line. So again, we have an electric dipole here. This is negative charge. Okay, positive charge. Length of the dipole is 2a. Here, this is our point S, where we have to find electric potential, which is at a distance r from the center of the dipole. So here at the point S, the negative charge produce an electric potential and positive charge produce an electric potential, and so we have to find what is total potential by adding potential due to negative charge and potential due to positive charge. So first we can calculate what is the distance to that point S. This distance from the center to the charge, it is A. Here it is also A, and this distance is R. So by Pythagoras theorem, this distance will be, okay, and this distance will be same root of R square plus A square. Here it is also root of R square plus A square is the distance. So now potential due to negative charge. What is potential due to negative charge? The V minus Q is equal to 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0, okay, Q by distance. What is distance? Root of R square plus A square, root of R square plus A square. And this is negative quantity. This is the potential due to a negative charge. So this is minus. Now find what is the potential due to positive charge. The V plus Q is equal to 1 by 4 pi epsilon 0 Q by root of R square plus A square. This will be a positive quantity. That's it. This will be a positive quantity because this is the potential due to positive charge. Now when you are finding what is the total potential at the point S, the total potential at the point S is the sum of these two quantity. Use algebraic addition for that. V is equal to V plus Q plus V minus Q. But you see that the magnitude of V plus Q and V minus Q are equal. When you are adding this two quantity, we are getting a 0 because V is equal to minus 1 by 4 pi epsilon 0 Q by root of R square plus A square, okay, plus 1 by 4 pi epsilon 0 Q by root of R square plus A square. So we are getting as 0. So our conclusion is that potential due to a dipole on its equatorial point, any point on its equatorial line, will be 0, and it have potential on its axial line, and we see what is the potential due to an electric dipole and axial line is equal to 1 by 4 pi epsilon 0 q by r square for a very short electric dipole.